direct this first question to you. So can you talk a little bit about your history in the machine learning area and how you got involved in this space? And also, how did you learn some of these skills yourself?
Yeah, so I basically got involved first in my master's. So I did my master's was scientific computing. So I did like a few machine learning modules in there. And then I was kind of talking to Chris at the same time about doing a master's project in reinforcement learning, which led on to the paper we talked about. Yeah, and then so I got basically very interested in reinforcement learning. Yeah, so I did like half a module in reinforcement learning, and then I kind of had to sort of learn the rest myself. But I think kind of so obviously machine learning has been like super hyped up over the like last few years or whatever. And I think one of the good things about that is there's loads and loads of like accessible materials to learn it. So you don't necessarily have to go and like pull through papers when you're starting out. There'll just be like a Medium article that you can read, and it will like tell you how to do it in like simple language, which is really good. So yeah, and then it just went from there basically. And then we started the Optimal Experimental Design project, which is like kind of another step up. So there's like a good book. I don't know if you want like a recommendation for a book.
Yeah, definitely.
The Sutton and Bartow book called Introduction to Reinforcement Learning, I believe is good. And then there's also this website called Spinning Up in Reinforcement Learning, which is really, really good. So it's basically like, so the Introduction to Reinforcement Learning is kind of like a good like first step. And then once you've done that, you can go on to Spinning Up, which basically it gives you like an overview of all of the kind of newer methods. So like basically a step up from like normal Q learning. And it also gives you like a summary of a lot of the different papers, and it just points you to a lot of the different papers. So that was also really good. So if you're going to do two things, I would suggest doing those if you wanted to learn reinforcement learning.
But are there things like that you recommend people do in terms of like a programming project to start, or like where would you find data, or how do you like do you have recommendations on things like that for getting started?
I mean, there's lots of like example. So for reinforcement learning specifically, there's like it's called the AI Gym, which has lots of different, basically like small reinforcement learning problems, which are quite well formulated. So you can kind of have a go at like implementing agents which will learn to do them. Yeah, I mean, basically you got to know how to program in Python, really. So that's definitely a good thing to learn. And then once you can do that, if you want to do deep reinforcement learning, you also got to learn like some kind of one of the neural network kind of libraries. So I use TensorFlow, but also PyTorch is widely used as well. So that's actually a lot. So especially TensorFlow. When I started, it was TensorFlow 1, which was much more difficult. But now they've made it a lot easier, and PyTorch is also quite nice as well.
Brian and Chris, I'm curious to hear from both of you. When you work with students or postdocs who are interested in getting started in machine learning, how do you recommend that they start out? Chris, let's start with you.
Well, just following on from what Neythen was suggesting, is I would start with a small problem. Start with a small relevant problem, but start simply, and then build up slowly. And I think online resources are great. There are some classic textbooks, depending on which area of machine learning you're working in. Also, what I explain is it does take time, So you have to allow that time, and you have to allow it to not work a lot of the time, and just to set expectations. But you get there eventually. That would be my advice.
Brian, do you want to add to that?
Yeah, no, I guess the only thing I could add is I think problem choice is really critical, because as we've already mentioned, there's been a lot of excitement about this area in a lot of places, And synthetic biology, systems biology, historically, the modeling efforts have often been data poor rather than data rich. And so this is an area where there's a lot of excitement, but one has to be very careful to choose a problem where it's going to be a good fit. And in this case, really, we're presenting more of a complement to existing tools rather than something that is a brand new solution. And I think in a lot of places, that's where we're going to see things as complementary to existing approaches. And that's maybe a good goal to seek rather than trying to throw this at everything that people are looking at.
Yeah, interesting. Okay. Do any of you have recommendations for like kind of good starter projects that are a little bit more synbio specific, either related to like time series data from bioreactors or sequence-based data, or like where would be an interesting place to start?
I can say something. I think that's quite a general question, but I think the supervised learning approaches that Neythen mentioned earlier, that for example, in synthetic biology, you might want to predict promoter expression. These require a lot of data, and if you use deep learning, there's only a few groups in the world that have the data. Unfortunately, the data's all out there. What we need is a giant synbio bioinformatics project that brings everybody's data together and allows us to do
clean and curated way. Right?
Exactly, because collecting the data is pretty much 95% of the battle, I think, for those projects. Mm-hmm. Reinforcement learning, as Neythen showed, requires less data. Mm-hmm. So that's why I think it was a good choice here, and I think it does depend. As Brian said as well, where you can complement existing methodologies, where perhaps you go beyond linear assumptions, or you tackle slightly more complex problems. I think that's the guideline. So if you can improve existing statistical approaches or control approaches, then I think that's probably the way to go.
I'll throw this out to any of you who want to answer this. Are there types of projects that aren't a good fit for machine learning? For people who are watching this and are curious about whether their research would benefit from the use of machine learning, do you have advice about what key ingredients need to be in place for a project to be successful?
Maybe I can say something again. I think general standard statistical approaches, linear regression is machine learning in a way, and I think you just have to be careful that, I know that there's buzzwords about machine learning and at the moment, but a lot of standard statistical techniques are adequate for most of the stuff we do. So, I think you do have to be careful that you don't, you're not over using these machinery where they're not quite needed.
Can I ask a little bit about, Brian and Chris, about your background and how you got into this space too? Would that work?
Yeah, I can say something. So I was trained as a physicist, and then I moved into more I did machine learning in particle physics, but then I moved into statistics and then into biology, so a bit of a mixture. But I think having a good statistical background and understanding data and inference, I think is a good grounding for all these methods, because there's a danger that you can apply these tools without really understanding what's going on under the hood. I think you need, it's good to have some understanding.
Yes.
How did you enter into working in this space?
So my background's in math. So I did work in control theory, and then have been working in biology for a while now, and then picking up basically statistical analyses along the way as needed for various projects. And that's basically the way I've come to machine learning as well, is not specifically as a goal, but because it's the right tool for certain projects and picking up individual pieces along the way. Yeah.
Nice.